the sun on the floor. And in this picture, you can see the big white circle there is actually like a pinhole camera. And the brass line is laid out in the floor exactly north and south. And that we'll get into why they did this in a minute. Okay, so astronomers call them meridian lines, and the Italians call them gnomons, not to be confused with your common garden gnome. So in the 1500s, each city in Italy was celebrating Easter on a different Sunday. Now, Easter is a movable holiday that's supposed to be on the first Sunday after the first full moon after the first day of spring, the vernal equinox. One problem was no one was sure when the first day of spring occurred. And I'm going to skip a couple of these slides here. The point of the highest noon is the first day of summer, and the point of lowest noon is the first day of winter. So this is an analemma taken once a week at noontime. And so you can see down here at the bottom is the first day of winter. Let me see if I can get my pointer back here. And then up here is the top, which is the first day of summer. And then you can see that if the Earth's orbit was circular, this would be a straight line, straight up and straight down. But the Earth's orbit is elliptical, and that's why it's a figure 8. And so we know springtime is someplace around in here someplace. So to solve this dispute, they started installing meridian lines, gnomons, in the floors of churches to calculate when the first day of spring occurred. Now this is how they would do it. They would have a brass rail in the floor that's laid out exactly north and south. And then they would have a small hole high on the wall or actually in the ceiling sometimes. So in the summertime, when the sun is high at noontime, it would shine through the oculus and it would be at the south end of the brass rail. And in the wintertime, when the sun is low at noontime, it would shine through the oculus and it'd be at the north end of the brass rail. So by counting 91 days forwards or backwards, they could come up with the first day of spring or the first day of fall. Now, the lines were simple in theory, but difficult to construct. The floor had to be perfectly level. The brass rail had to be laid out exactly north and south. The oculus had to be directly above the brass rail, either in the roof or high on the wall. And on the right here, you can see one of the Pope's private chapels. And you can see that he's got his oculus in the wall here, and you have a beam of sunlight coming down, and he's got a big circle for the first day of spring. And then you can see the brass rail that tells you when noontime occurs all year long. So this is a typical footprint of most of the cathedrals, and it was fairly easy to put the brass rail someplace on the inside of the church. As long as the church was oriented north and south, the brass rail would fit just about anywhere. Now, when the church is oriented east and west, that means that the brass rail had to come across the short part of the church. And I'll show you how they solved that problem in a couple more slides. This is San Petronio's Duomo in Bologna. And that just means St. Peter's Cathedral in Bologna, Italy. And you can see on the right here, this it looks like they ran out of marble halfway up the cathedral. But when you go inside, you can see that there's a beautiful Baroque church inside. And you can see the brass rail embedded in the floor. And then you can see they have a box here for the first day of spring. And here you can see an image of the sun as it's passing the brass rail at noontime. Now, this is the longest meridian in Italy at 219 feet. And when I went to Bologna, I got there on a Sunday, and the cathedral is closed to tourists on Sundays because they have mass. And so I went back to my hotel and changed my clothes and put on my best clothes and turned off all the bells and whistles on my camera. And then I went to mass. And so I was sitting in the pews, and I was trying to take a picture of the oculus up on the roof up here. So I think I'll probably be spending a little time in purgatory for being sacrilegious. Now, here's some of the other boxes that they have. They have one, for the different signs of the zodiac. And here's one. I think this is the first day of spring here. I was very close. I was just a few days past the first day of spring when I got that image of the sun passing the brass rail. Now, this is the picture on the right is taken from the oculus looking down, and you can see how small the people are down here. And then on the right side, you can see a footprint of the cathedral, and these large black dots are these giant columns. And you can see how they had to fit this meridian line, this gnomon, in between those two columns to get it to fit.
On the image of the sun, when it's on, hey, is it possible to see sunspots?
Not on this one. No, the image is a little on the fuzzy side. Now, I said that this gnomon was 219 feet long. Now, it takes the sun 182 days to go from the first day of summer to the first day of winter, which means that the image of the sun moves more than a foot each day. So it's very easy to keep track of the days of the year. Now, this is one of my favorite churches in Rome, St. Mary's of the Angels and Martyrs. And the outside kind of looks like a Roman ruin. And you go inside and it's a beautiful Baroque church. And this one, the oculus, is on the wall rather than in the ceiling, and they have this gold shield around it. And then you can see the very small hole where the light is coming through. And down here, you can see where they had to cut part of this marble facade in order to get the beam of light to come through and shine on the brass rail and the floor. Now, this is what it looks like from standing down on the brass rail. You can see the gold shield up here, and you can't quite see the sun coming through there. I didn't have my camera in the right spot, but you can clearly see the V where they had to cut in order to get that beam of light to come through and hit the brass rail. Now, the picture on the right, I had my camera looking right up at the oculus, and that's what the sun looks like as it comes through that very tiny hole. Now, there's a ratio between the size of the hole and the height of the hole, and the ratio is 1,000 to 1. So if it's 100 meters up, it's only going to be about 1 inch around. So it's a very tiny pinhole camera. This is what it looks like from overhead. And you can see they've got the angles, the days of the year. all engraved and inlaid in the marble tiles. And the reason I like this church is that this church recognizes the significance of their gnomon. Many churches I've gone to have got they don't even know if they have a gnomon in their church, or if they do, they have it covered up with rugs, or they have no idea why it was built or how it was used. But this church has got pamphlets in 7 languages that tells you how it was built, why it was built, and how it's used. And here is the box for the first day of spring right here. And you can see that they've got some little measuring brass rulers right here. Now remember that we have a leap year once every 4 years. So the sun's image is going to be moving along this line 1/4 of a day for 4 years, and then it's going to plop back to where it started. So that's the way they took care of leap years. And then here's the Tropic of Cancer here, which is the first day of summer. This is one place where you're not going to find a gnomon. And this is the Duomo in Venice. This is St. Mark's Square. And this is the cathedral there. And the reason you won't find one there is because this church was built on wooden pilings driven into the mud. And over the centuries, the pilings have stayed the same while the floor has sunk. So now the floor is undulating and it goes up and down about a foot, about every 4 or 5 feet throughout the church. So remember, I said one of the requirements for a gnomon was the floor had to be perfectly flat. So you know, if you happen to find one inside of Venice, let me know and I'll go and take a second look. This is the Duomo in Milan. And this one, you walk right in the door. This is the door to enter. And here's the gnomon right here. It's 5 feet inside the door. Now this one is built across this church is oriented east and west. So the gnomon goes across the short length of the church. Now they solved this problem is when they got to the north wall, they just went right up the wall, and the first day of winter is about 7 feet off the floor. And this was a rather simple one. I just had the signs of the zodiac on it. So here you can see Sagittarius and Libra. And this is the large cathedral in Florence, Santa Maria del Fiore. Now this one has got the tallest oculus in Italy. And I'll see if I can get a picture up of that one. And this is the top of the dome up here. They have a glass, clear glass structure. And this is where they put their oculus. And their oculus is on this flat plate put into the stonework. And if they were trying to put in an entire gnomon in here, it would be over 500 feet long. So all they did was they only had room to put in about 3 weeks. And then that included the week when the first day of spring would occur. Now, this rectangular part of the church is open to the public. And when you come in, you can walk around here all you want, but you're not allowed to go underneath the dome. And if you look on the north transept right here, you can see a little red line, and that is the gnomon for this church. And you can see a red dot there. That is for the first day of spring. Now, they wouldn't let me go into the north transept. So these are all confessionals right here. So I told them I wanted to go to confession. And as soon as I got in there, I made a beeline for the north transept. And the guards caught me before I got too far. But that's some more time in purgatory for me. Yeah, let me see. It looks like we're frozen up here. Okay. This is the north transept. And you can see right here that here's the north-south line. And then here's the circle for the first day of spring. Now, the reason they don't let any tourists in there is because this is painted on the floor. It's not inlaid the way a lot of the other gnomons are. So this has been walked on for 500 years at least, probably 900 years. And so it's in very bad shape. So unless you're an astrophysicist, you're not going to get an invitation to take a look at this. It's covered up with steel plates and covered up with rugs. And this is just another look at the Santa Maria del Fiore. And then you can see where the oculus is way up on top of this dome. And this is the baptistry across the street. It has an opening at the very top of the roof, and it shines down, and it just shows where the first day of spring is. It doesn't have a complete meridian line at all. It just has that one point on the floor. Now this is Santa Maria Novella, also in Florence. And this one has got 2 meridian lines in it. This used to be the main cathedral before they built the giant cathedral. And this one, the first oculus is right here in this stained glass window. And then the second oculus is right above it, or right in the center. And here you can see the there's 2 red lines here and 3 blue ones. The 2 red ones are for the upper oculus, and they didn't have room to put in the first day of winter. All they have is the first day of summer and the first day of spring. And then the lower one has room for all 3. It's got the first day of summer, first day of spring, and first day of winter. And these just about go down the center of the aisle of the church. So it's very easy to pick these out. So this picture on the left is the first day of summer. And these tiles are about 2 feet by 2 feet. And so that image of the sun where the first day of summer is probably only about 8 inches around. Now you'll see how that stretches out. By the time we get to the first day of spring, you can see it's already starting to look like a watermelon. And here you can see the oculus for the first line is a small hole in this stained glass window. And then the oculus for the second one is directly above the window, right in the center. And here you can see the first day of winter, and you can see how this is stretched out. Now, I said these tiles are about 2 feet by 2 feet. So by the time it gets to the first day of winter, that image of the sun is now stretched out to a little bit over 6 feet. So after studying the meridian lines, a solution was proposed. In 1582, Pope Gregory XIII decreed the day after Thursday, October 4th, 1582, would be Friday, October 15th, 1582. And century years would only be leap years if they're evenly divisible by 400. So 2000 was a leap year. However, 1700, 1800, and 1900 were not leap years. So we have a picture of Pope Gregory here on the right. And on the left here, you can see the people were not happy with the new calendar. Now, the Bible says that each man has a certain number of days on earth, and the Pope had just lopped 11 days out of your lifetime. Now, if you're wondering why the Greek Orthodox and Russian Orthodox churches celebrate Christmas and Easter a week after the rest of the Christian world, it's because they never changed to the Gregorian calendar. They're still using the Julian calendar. Now, I found one other meridian line, and this one is at Saint-Sulpice in Paris. And this one was built 160 years after the new calendar was established, but they used the gnomon to ring their church bells at noontime when the image of the sun hit the brass rail, and they would all reset their clocks to noon. But the actual purpose of the gnomon was to measure the tilt of the Earth's axis at perihelion when Earth is closest to the sun. And here, this one, this church is oriented east and west. So this goes across the short axis of the church. And you can see here, we have a box for the first day of summer. And then coming across, and the first day of spring is about here, just before the altar. And then the first day of winter is way up this obelisk on the north wall. Now this one, if you look closely, you should be able to see a very small hole up here. There's a iron plate over one of the frosted glass window panes. And that is the oculus for this gnomon. And what they do on this one, you asked me whether you can see sunspots or prominences or anything like that. On this one, you can. They have 3 lenses that they put in that oculus, and the focal length is exactly correct for the first day of summer, the first day of spring, and the first day of winter. And what they do is the image will come out crisp and clear, and you can see sunspots and you can see solar prominences only when they have those lenses in, which is only happens 3 times a year. And here's a disc for the first day of spring. And this is just a close-up of the first day of summer. And I thought this was kind of interesting. This tablet was at the base of that obelisk. And it used to say that, you know, this meridian line was installed, you know, with funds from Louis XVI. But after the French Revolution, they wanted no mention of any royalty. So what they did is they obliterated any mention of Louis XVI here, and they also obliterated the royal seals on here. And this is what the image looks like without the lenses in to sharpen the image. And you can see how fuzzy it is on the edges. And this, I think we can skip. I think we all know how the Earth moves around. the sun, and the equation of time. And these are a couple books that go into detail about the gnomons in Italy. One is Chasing the Sun by Richard Cohen, and he's got 2 or 3 chapters on gnomons. And the other is The Sun in the Church, which details just about every church in Italy that has a gnomon inside it. So if you have any questions, you can go to my website, garytheastronomer.com, or you can email me, garytheastronomer@gmail.com. So is there any questions?
Yeah, I was wondering, obviously you were homed in on the churches in Italy. Are you aware of other churches in Europe that have gnomons like this?
No, I think Italy was unique. It's because the Italy was divided into city-states at the time. So there was a king of Naples, there was a king of Florence, there was a king of Pisa, and a king of Milan, and so on. And so whenever the king celebrated Easter, that's when your kingdom would celebrate Easter. Now, I don't think that situation was happening in other countries in Europe.
I was wondering also, they have a setup over there at the Griffith Observatory with a gnomon. And, I think it's at every local noontime, they have the guys go out there with a trumpet or something to announce that it's, the sun is passing the meridian. Have you seen that one?
Yes, I have, and it's very unique. It has a photoelectric cell along the length of the gnomon. And so when the sun shines through the oculus and it hits a part of the brass rail, it's on a very curved sculpture type of thing, that will light up a light on a board that'll show you what day of the year it is.
Yes.
So it is, yeah, if you can get there right at noontime, local noontime, not Pacific time or daylight savings time or anything like that, but at local noontime, yeah, it's very interesting to watch it.
Yeah, I thought that was very well planned.
Yes, it is.
And so speaking of planning, were most of these things in the Italian cathedrals retrofitted? It was done after the cathedral was already built, or were any of them part of the construction?
No, absolutely. They were all retrofitted. Most of these cathedrals were built in the 9th, 10th, and 11th centuries, and the gnomons were not put in until the 1500s. Now, the Jesuits were the astronomers for the Vatican, and they were the ones that would figure out how to get the north-south line in, where to put the oculus, how big a hole to make, and where to put the first day of spring in. And the cardinals were very competitive, and so each one of the cardinals wanted to be the ones to tell the Pope how to change the calendar. So once they started putting in these gnomons, they all wanted the Jesuits to come and do their cathedral in their hometown. So that's why just about any cathedral that had a cardinal is going to have a gnomon in it, because the cardinals wanted to get in good with the Pope by telling him how to change the calendar.
And make sure they had Easter at the right time was the whole.
That's right. They want to make sure everybody celebrates Easter at the same time.
And yet, to fast forward to today, And not all the cathedrals is it recognized that this even exists in their building.
Yes, I mean, when I started talking to the I don't know what they're called, Setons, or whoever was in charge of the Catholic churches, the physical buildings. I would get blank stares, and they would look at me like I had three heads when I was asking if they had a gnomon in the church. And it's a shame, because these are all beautiful, they're all unique, and they're just so fascinating that they use such simple technology to solve a very complex problem.
Gary, can I ask a question?
Certainly.
I'm sorry to have tuned in so late, but couldn't help that. But this is something I've been wondering about for a long time. I can't quite get my head around it. The Earth's axis, precesses over, I think it's a 26,000 year cycle. Does that throw these things off? I mean, 500 years, 600 years from when they were built to today, seems like that could be a factor if precession is a problem.
I don't think it is. The Earth's axis precesses, but it does not precess by hundreds of miles. I think it precesses by maybe 1,000 yards in 25,000 years. It isn't that big. It isn't that big a change. I mean, we can detect it with the equipment we have now, but I don't think they could detect it, back in the 1500s when these gnomons were installed.
Well, that's interesting. My understanding was that Polaris is our North Star now, but in 13,000 years, it'll be, oh gosh, what?
It's going to be Vega.
Deneb or something.
Yeah, I think it's going to be Vega.
Okay, and so that seems huge to me.
The stars move, but they move very, very slowly.
Oh.
And remember, what we're doing is we're using the sun to calculate when Easter was going to occur. We weren't using the stars.
So as long as our relationship with the sun stays the same, then
Yeah.
gnomons will still work.
Yeah, as long as we don't have a red giant, well, I think we're going to be all set for a few thousand years. By changing the way centuries are determined whether to be a leap year or not, they have to be evenly divisible by 400. That makes the calendar accurate to 1 day every 1,000 years. So it's not going to be off that much, in our lifetimes anyway.
I'm thinking, I wish we had an astronomer, a real astronomer here in case, but I'm thinking that then in 13,000 years in the Northern Hemisphere, summer will start in December, and spring, or winter will start in June, right?
It's possible. Like I said, by changing to the Gregorian calendar, it is accurate to 1 day for 1,000 years. So yes, so in 13,000 years, it would be 13 days off.
But the axis will be pointing exactly the opposite direction, when half a cycle of precession is finished.
Yeah, like I said, I'm not so sure I know that much about the precession to know how much it actually moves, over the course of 23,000 years or whatever the cycle is. But yes, I do know that it does move. But
Barry, can you back up a couple of slides? You had a picture of the Earth with some markings on it. That might help us understand this better.
okay,
One more maybe. Well, we can use this one. Let's see. Maybe I'm off. I think there was one showing different axis tilts.
yeah, I think let me see.
Hmm. Yeah, maybe I'm not remembering right.
No, I think you're right. I do have a slide here that I kind of slipped past you. There it is. So today's
Yeah.
tilt 23.5 degrees.
Yeah. So, if we extend the plane of the Earth's orbit out, the sun will be over there to the left. And
Yeah.
so that would be summertime in the southern hemisphere. But now if we flip the Earth's axis over to the other side in 13,000 years, then at that point in the Earth's orbit, it would be summer in the northern hemisphere. That makes
Yes.
sense.
Well, that's what I was saying. I don't think the precession is that large. You know, I think precession might be less than a mile.
Yeah. It's a hard one.
Well, I'm sure somebody can Google that. If there's any other questions.
How long did it take you to get to all these churches?
Oh, it took me 3 weeks the first time I went looking. And in those 3 weeks, I had calculated the latitude and longitude of all the churches I was going to visit. And I had calculated when noontime was going to occur. And in those 3 weeks and all the cities that I visited, I never once saw the image of the sun hit the brass rail. So when I got to Paris and I got to Saint-Sulpice, it was 2 hours before local noontime. And so I sat down and prayed for 2 hours, and I finally got to see the brass rail lit up by the sun's image. So perhaps God wasn't as mad at me as I thought he was. So. But anyway, thank you for having me, and hope you enjoyed it. And if you think of any questions later on, be sure and email me. And if you go to my website, GaryTheAstronomer.com, this whole lecture is on there if you want to see it again. And plus, there's a lot more stuff about eclipses and Machu Picchu and all kinds of different things.
Okay. Well, thank you very much.
You're
Thank you.
certainly welcome.